Welcome to Thai Award Unveil 2022.
I'm Etta, and I'm the CEO of Perfect.
We Thai with Taiwan.
All right, good morning, ladies and gentlemen. Welcome to Thai World Unveil 2022. I'm your MC today. My name is Rebecca. In order to build an international hub in Taiwan, the organizer, National Science and Technology Council, debuted the first ever Thai Award, the Tech Innovation Excellence Award, to attract global ICT solutions into Taiwan and to create new business opportunities and also some new partnerships with other countries and our members. The award is focused on innovative applications within one of the 7 designated categories, including AI and AIoT, efficient energy conservation, and communications and satellite, and smart manufacturing, autonomous vehicles, and new energy, and also sensors. And this year, Thai Awards received 119 applications from 25 countries, and 30 of the teams entered to the finals. And the judges have selected final 11 top winners from home and abroad to receive the awards here in Taiwan. And the award ceremony will be held on the 15th of October, which is the Saturday. And but today, you're about to meet all of them on stage just later. But before we begin, I would like to welcome the Director General of Department of Academia, Industry, Collaboration, and Science Park Affairs at National Science and Technology Council, Ms. Andrea Xu. 让我们掌声欢迎国科会产学处的许增如处长为我们来做开场致辞。
Thank you. TIE Award-winning teams, distinguished industry partners, distinguished guests, ladies and gentlemen, good morning. I'm Andrea Xu, the Director General of National Science and Technology Council, NSTC. On behalf of NSTC, I'm honored to welcome you all to TIE Award Unveil. Now with the pandemic behind us, NSTC is really excited to go full steam ahead with our mission to facilitate innovative technology application and to drive Taiwan industry forward. And this is why NSTC organized the first ever TIE Award this year, highlighting Taiwan world-renowned industries. The goal of this award is to attract the top startups and research teams from the world to join our high-tech supply chain. The TIE Award Unveil today features 11 outstanding teams, and which have been meticulously selected from 119 applicants in around 25 countries. Their technology covers the fields of energy conservation, metaverse, satellite communication, smart manufacturing, and more. We hope our effort will empower our TIE Award winners to establish the connection necessary to take their innovation forward through partnership and collaboration. I would like to take this opportunity to express my appreciation for the dedication of my colleagues. The team that put this award and the event together in such a short period of time. It wasn't easy, but we did it. Let's give them a round of applause. Last but not least, a big thank you to all the staffs and research teams who enter our TIE Award competition. You all have made the TIE Award a truly international award. We look forward to holding the TIE Award annually and building up its reputation to become of the world's most prestigious tech award. Similarly to the Innovation Award at CES and FIFA Tech Publica, I'm truly grateful to all those involved in making the first TIE Award such a great success. Thank you, everyone. Thank you.
Thank you. Thank you, Director General Xu. Please remain on stage. Right now, I would like to welcome and invite all of our winners to be on stage to have a group photos together. So please follow our staff to be on stage. We would like to take a group photo in the very beginning of the TIE Award unveil today with all the 11 winners on stage. All right, if you're comfortable, please take your mask off. Thank you. Yeah. All right. All right, everyone, please look at the camera in the center first. All right, thank you. Smile. Look at the camera in the center. Please have your thumbs up. Thumbs up to TIE Award. Please look at the camera a little bit on your right-hand side here. Over here. Okay. Thank you. Thank you so much. Please kindly take your seats. 我们也谢谢许真如处长为我们所做开场致辞，同时呢，也跟我们所有的 winners 一起进行合影。All right, now I would like to move on to today's event. First of all, I would like to have our 8 honorable mention winners. And first of all, the first team, they came all the way from Virginia, United States, the Virginia Tech Future Energy Electronics Center. And they have been focusing on the high efficiency, high voltage power, and the power conversation. So now, ladies and gentlemen, please welcome the director, Jason Lai. Welcome.
Thank you. Okay. My topic is a little bit complicated. Let me show you what I'm talking about. The topic says wide bandgap devices. Wide bandgap third generation gallium nitride and silicon carbide device. And we use that for inverter application. So what is inverter? You know Thomas Edison and Nikola Tesla. Thomas Edison says, I want DC, and Nikola Tesla says, AC is better. So inverter is for them to shake the hand. Okay, between AC and DC, I get the DC, and I convert it to AC. Okay, so now let's start what we're doing. This is our invention. We use the cascaded waveform instead of pulse-width modulation. So efficiency is extremely high. Okay, we can get 99% efficiency. We can use that for electric vehicle, solar PV application, the wind, and all the renewables and transportations. Okay, so you can see the stacking voltage. We don't need very high frequency switching. Okay, look at, if I stack more and more, I can get very high voltage. And efficiency is still 99%. And our transformer is running at 1 megahertz switching. Okay, you know our utility is 60 hertz. So we reduce the size of the transformer by 200 times. Okay, so that is our core technology. So then we can stack it for utility application at 11 kV or even 22 kV for Taiwan system. Now, this is a three-phase, 100 kilowatt, 11 kV that we have the demonstration there. It's a terminology we call binary multi-level inverter. Binary means you use 1, 2, 4, or even more to stack it up, and the combination gives you a lot of voltage levels that matches with the sinusoidal waveform, so you don't need a filter, and it's very efficient. Okay, so the system can be integrated into a DC grid, and the DC grid can be used for fast charger, and then you can take the source of the PV source and use that for all the high voltage or low voltage load with the advanced inverter. Now, if I just compare the PV system, that the top picture is Japanese 1 megawatt PV inverter, and they weight 5 tons. 5 tons. It's impossible to carry. And ours is, if you look at 100 kilowatt, it's no more than 20 kilograms. You can hand carry it, and the size reduction and the weight reduction is dramatic. Okay, and all because we are using wide bandgap device, gallium nitride and silicon carbide. Now, this is another example. The existing fast chargers is to convert high voltage to low voltage, and then send the 1,000 ampere to the charging station. And you can think about the loss of the cable and the expense of the cable, and then you can charge the car. So what we do is get rid of that transformer and just 2 units. The other one is no more than 90%. If you think about the whole system, this one, you can get 98, 99%. So if I just look at Taiwanese market, we say about 25 or 12,500 charging stations altogether, we can save 125 megawatt, which is about 1 hydro plant. Okay, so that is energy saving aspect. Now, you have not just the energy saving aspect, you can also look at the future electrification target. In 2025, the market for Taiwanese charging station is already 2,500. And then today's PV installation is 7 gigawatt. And then in 2025, which is only 3 years from now, we're shooting for, this is government shooting for 25 gigawatt. So this energy saving for PV, for EV charging altogether is incredible. Okay, so this is our team. Due to the pandemic, my team is much smaller. It used to be 3 times like this, but right now it's enough to carry on. We won the Little Box Challenge that in 2016, Google Little Box Challenge for inverter application, and we won the Solar Prize, the 3rd round, the American-made Solar Prize competition, and we have collaboration with E3, with RIMAS, the Taiwanese companies, to win this kind of award. So in the end, I want to show the local integration. I have a pretty good, strong tie, because personally I'm from Taiwan. So I have strong tie with Taiwanese industries for system integration, for component manufacturing. In fact, some of the components is already on the market. And I'm also affiliated with National Yangmin Jiao Tong University, and E3, and Pegatron, all the companies that you may know or may not know, big companies. Okay, so for this competition, we think about, we want to have application for innovation, which I consider the efficiency is number one contribution. And then we can apply to the energy, the electric transportation systems. And then we want to incorporate our technology to boost the Taiwanese industry to take the leadership, not just in semiconductor manufacturing, but also in application, okay, which I think we are a little behind, but I can help. Then for the value creation, we can think about the saving of hundreds of megawatt power and the saving of even an entire power plant in Taiwan. Okay, and then the local integration, I already emphasized that it's our goal to promote the advanced technologies for Taiwan. So thank you for this opportunity.
Thank you, Director Lai, for the wonderful presentation. And next, I would like to introduce Mechavision Incorporation. It is an innovation spin-off company from ITRI, a world-leading applied technology research institute in Taiwan. And the team specializes in research and development of robotic textile technology. So now please join me to welcome the chairman and CSO, Dr. Ken Masu. Welcome.
Good morning, everyone. I'm Kemas. I'm the founder and chairman of Touche Solution. In the past decade for manufacturing, operators usually work side by side, but we put robot inside the cage. That's our only method for automation so far. But if we want to transform a traditional manufacturing plant into a smart factory in a way that is flexible and productive, there are always challenges in safety, space, speed, and automation complexity, which means cost. And that is why there is a big trend in human-robot collaboration. We want to move the robot inside the fence to robots who can sharing the workspace with humans and even collaborating with humans. It's not only just in industrial environment, but it will be in everywhere, from hospital to kitchen to restaurant and for warehouse application. However, the more intelligent of a robot for collaboration, the more possibility for physical contact between human and the robot. So the collision risk is increasing in the future. Imagine if we can easily upgrade your robot to work safely with your people. We are making it a reality with T-Skin, a tactile skin, which can easily upgrade your industrial robot to safely co-work together along your operators. T-Skin is a surface sensing device which can detect all abnormal contact on the surface. Okay. So T-Skin is also compliant with new ISO standard for power and force limiting safety function. We provide a contact stop to protect the human from being injured by robot. And therefore, there are only limited power and impact from the robot to human body. It's all under ISO TS 15066 biomechanical limitation. Okay. Our global compliance with all international certification in safety and health enables our customer to solidify their requirement all around the world. So we have a rich portfolio of T-Skin to upgrade all industrial robots for a safe collaborative application, from Scala robot to 6-axis arm robot. And also we have a design-in skin. We co-work with a leading company for their next generation robot. Here is a short video of the new concept of robot skin. All the skins are attached on the surface of industrial robot. So the outcome is a high-performance industrial cobot with zero compromise. We have partnership with many top industrial robot manufacturers, either co-develop with their headquarters for next generation robot, or we go co-marketing and sales with their local branch for all existing robots. So in my conclusion, for smart manufacturing, we all know robot can help, and T-Skin is helping. Okay, robot with T-Skin automation can enhance your workplace safety and make your quick production line be flexible and reconfigurable, and increase your productivity, and in the same time stay in competitive. Okay, that's all my presentation today, and I'm very enjoying this stage. So if you have any question or interesting, please contact to share solutions. Thank you.
Thank you, Dr. Kamatsu. Please kindly return to your seats. Thank you. And next up is Nanoward. It's from Germany and was spun off from the Technical University of Darmstadt. And the company develops NanoWeld, a disruptive 3D integration technique based on nanotechnology. So now, ladies and gentlemen, please welcome the CEO, Mr. Olaf Berlam. Welcome.
Hello.
Hello.
My name is Olaf Berlam. I'm coming from Germany. And as I was a child, I had a dream to reduce pollution worldwide. Today, I'm the CEO of Nanowired, and we've got developed the resistant-free electrical contact. And this fast, flexible, and scalable in a size between 3 micron and 300 millimeter. We do it on semiconductors, on PCB, FPC, LTC, and all substrates, but just start with the technology itself. Whom of you has, for example, a mobile? Do you have ever had the problem that the battery inside was empty as you want to make a phone call, or that you had a hot ear after a long call? This are the electronic losses inside these electronics. And the losses, this energy you can't use for the things that you want to do, like gambling, telephone, or to navigate to the next system. So let's look how these electronics is joined inside. So you've got solder technology, you've got bond wire technology or silver sintering. But all these technologies has their limits in the application. The best mechanical, electrical, and thermal material in the world is copper. But copper has a problem. Copper has a melting point at 1080 degrees, so it's not easy to solder. Copper has a corrosion problem everyone talks about, but we have solved this copper can't make a direct joining. So we invented something that we solve all this, because we, from Nanowired, don't melt, we just grow nanowires on substrates and then stick them together like Lego. And during this millisecond process, we make an ideal electrical and thermal contact. And so I invite all these high power frequency converter producers to use this technology just to eliminate all these electrical losses inside. So we are the one who made the copper Velcro. So how does this miracle appear in the application? So you've got only 4 simple steps. First, we make a masking, so we define by a lithography process where the pad has to be. And lithography, this is a principle that works very well. You've got the machines on site. Then there is only one additional step, the nanowiring process. This is a magic machine that then creates on the substrate, in the place where you want these turf structure, where then later on you can stick them together. And at the end, you're ready. No hot process anymore. So what are the advantages of this new technology? First, 2D, 3D integration. So we stack multiple hybrid material over each other. And now think about the nanowires. They've got the length of, for example, microns. And then you can stick them and eliminate all these mechanical distances in between. So we don't melt, we stick, so we don't have capillary force treated shortcuts, and pure copper has an ideal electrical contact. So we are ready to be integrated in the production line because it's only one additional step, and everyone inside this production line has an advantage. So we reduce the costs and we eliminate additional production steps. So out of this, we shrink this to 3 micron and make 3D integration. And an ideal thermal contract with 350 megawatt per meter Kelvin to eliminate the electrical and the thermal throughput. And we are here. We are in Taiwan. Nanowired has yesterday, with a big opening, started the technology center here. So we are ready for you to bring the technology to you. So we invite you to reduce your costs and start your integration project with the nanowiring technology. Nanowire, the company with the copper Velcro, we eliminate all electric losses. Thank you.
Thank you, Olaf, for your presentation. Thank you so much. All right, and next up, we have a team from National Taiwan University, which is currently operated in the Unicorn program of the Ministry of Economic Affairs, Taiwan. And it is operated within the NTU Athena Technology Research Team. So, ladies and gentlemen, now please welcome Professor Shizhen Zhou to be on stage. Welcome, Professor Zhou.
Okay, so good morning. And I'm from university. Of course, you know this from National Taiwan University. Okay, so I'm a research organization. So in today's presentation, I cannot talk too much fancy stuff, but I'm going to tell you the truth and tell you what we have tomorrow. Okay. So let's try to see our topic here. Our topic we call low cost. It's a keyword. The keyword is low cost because now people are talking about the future application of telecommunication. They are very interested in LEO satellite communication, and they think that this is our future. Of course, we think the same thing because if you have the opportunity to look back to our past telecom communication, we know the IoT is the most important application. And they kind of focus on low frequency band. What do we mean low frequency band? The frequency below 3.5 gigahertz. So we can have 4G, we can have 5G, and we can have Wi-Fi application. But if we look into the future, what's our future here? We believe that the satellite communication may be another blue sea we will have for tomorrow telecom industry. Okay, so here I'm just going to show you some information that the research organization already show you. But I'm going to focus on what? I'm going to focus on the keyword here. We have the boundless opportunity. So what do we mean boundless opportunity? Because we believe that in the future, when we talk about the IoT application, we want them to be everywhere. Then where can we have that? The United Nations also estimate that there are more than 40% population. Right now, they don't have internet connection. So this is our opportunity. And this is the solution the university research team are working now to resolve the current difficulty and try to resolve the current bottleneck. What's the bottleneck right now we have? The cost, the complexity of the system. Because if you have opportunity to look at the solution, you see from the newspaper, you know that, for example, Starlink, they show you a solution of user terminal. But if you try to estimate their cost, they tell you that the cost is more than $2,000 US. Okay? And if you also have opportunity to talk with the IC supplier, they also tell you that each chip costs you more than $80 US. Okay? Okay, so in terms of assembly, to build a UT terminal, you need to have more than 200 chips or even more than 1,000 chips. And in that case, how can you make everything simple? How can you make everything cheap? Okay, so here is the key slide that I will share with you today. You can see we have some product in the market, and this is our solution here. And looking at the solution, we can find in the market, you can see they are very beautiful. They show you that they are all in one solution. You just need to buy one and you solve everything. But if you look carefully on the fabrication or the structure of the solution, you see that this kind of solution will give you a lot of problems. The first problem you will have is that you have all one solution. What happens if one chip fails? What happens if some chip fails? Then this solution, you need to repair. Who can repair for you? Okay, so in this case, you can see that the problem is that you need to find some way to make it simple. Try to find some way to make it repair more easily. And even you need to find some way to reduce the cost, to reduce the complexity. So our research team, our target is that we try to develop all kinds of antenna technology. They'll have you to do this. Okay, so you can see our solution here is that it's very compact because we are not all in one, but we make them in terms of module. So what the benefit of module? You can replace it very easily. And we have all kinds of tools that you can detect the failure chip right away. And most importantly is that we have some technology that can repair the solution online, which means that in the future, when you have something wrong with your terminal, we don't go back to the fabrication factory or go back to the store to repair it. We can do it online. Actually, online repair will be the future trend for the IT equipment. For example, when you use the iPhone, you found that you have some problem with the battery, then what do they do? With Apple, they just replace the iOS for you, okay? And the most important one is that we developed some kind of material we call intelligence material. And this material can allow you to reduce the antenna element. They can perform the beam scan, which means that we can find the minimum number of RF chips we need. Okay, so this is quite an important technology for the future LEOS UT terminal. And our research team are kind of, we also wish to jump into the market. So we are kind of learn different kind of stage to try to promote our solution, and we also try to spin off a company. And this company has been registered, okay? So our research team work on the user terminal, and we also work on the payload of the satellite. And we also do all kinds of antenna system design for the solution. So I wanted to emphasize that this is the new era of telecommunication, especially very important for Taiwan industry. Okay, so let me give you my conclusion here. The LEO satellite, we have a dream, and this dream is ongoing. But the big game just begin. You are not too late. Which means that based on your business model or anything you can think of, we have full of opportunity. And the LEO satellite application will be a revolutionary blue sea and the final paradise for IT industry. Okay, so new era, new industry trend, and we wish that we have a full opportunity for Taiwan industry. Okay, so thank you for listening here today. Thank you very much.
Thank you, Professor Zhou, for your presentation. Please kindly take your seats. Thank you. And next up, I would like to introduce NanoBridge Semiconductor, which is a spin-off company from NEC Japan and founded in 2019. And the founding members work at NEC Central Research Laboratories for many years. And currently, they're conducting a chip manufacturing contract business using original NanoBridge NB technology. So now, ladies and gentlemen, please welcome Mr. Tadahiko Tsukubayashi, the co-founder and CEO of NanoBridge, here with us. Welcome.
Hello. My name is Tadahiko Tsukubayashi. I'm a co-founder and the CEO of NanoBridge Semiconductor, NBS. NBS is a spin-off from NEC Japan, and it was founded in 2019. We hold more than 100 patents about a unique semiconductor technology called NanoBridge. I'll explain NBS and its product, NanoBridge FPGA. As shown in this figure, AI systems that perform inference on IoT devices and learning on the cloud are expected to spread in near future. In such systems, one of the major problems of IoT devices is power consumption of semiconductor chips. And another issue that mission-critical devices like satellites account for is radiation error. On top of that, semiconductor chips for AI processing are expensive to produce. NanoBridge technology can solve all three problems at the same time. NanoBridge is a quite small switching element, below 10 nanometers, made with copper atoms. Thanks to the technology, we produce a new generation of FPGA chips that feature 10 times lower power consumption, zero radiation error, and 20% lower manufacturing cost. Since the circuit mapped on FPGAs can be updated, FPGAs are well suited for implementing AI inference on IoT devices. FPGAs contain many routing switches to make the circuit reprogrammable. NanoBridge is very small routing switch compared to CMOS transistors. So the small size reduces the chip size of NanoBridge FPGA by a factor of 4. NanoBridge turns on when a voltage higher than the threshold is applied across its two terminals. It turns off when a reverse voltage is applied. It can be manufactured in a normal semiconductor factory with a few additional processes. In 2020, we demonstrated radiation resistance of nanobit FPGA in satellite orbit. This demonstration was conducted under the JAXA program. NBS is already working with some aerospace clients in Japan. And we closed 2020 with over $1.1 million in revenue. By adding licensing to the current business model, we aim to generate $50 million in 2026. I have extensive experience for semiconductor development and business in NEC. Our team has domain expertise and deep knowledge of both tech and business. Thank you very much for your attention.
ありがとう。高彦月林さん Thank you. And next up, Deep Mentor is a total system design service company and established in June 2018. And the core team members are from Logos Lab of National Tsinghua University, Taiwan. One of Logos Lab's research area is electronic design automation, EDA. So now please join me to welcome the CEO, Jack Wu. Welcome.
Hello everyone, I'm Jack and I'm the CEO of the Deep Mentor. Deep Mentor is a very new company and we start from the 2018 and all of our members is from the Tsinghua University's Logos Lab. And what we do is we do a Edge AI deployment total solution. Why we have this idea? Because we think there are troubles in cloud AI. The trouble of cloud AI is the latency. For example, if you want to use automation vehicles, you do not want the cloud to handle all the AI process because the latency can make the driver into dangerous situation. And for automation vehicles, for industrial automation, you all have the same problems. How to solve the zero latency requirement of this situation. We find many solutions to solve this problem, but finally we think we need to deploy the Edge AI, plug the cloud AI into the edge device to solve this problem. But when we solve these problems, we find a very interesting result. The Edge AI is not an arrogant problem or a cheap problem. It's a system problem. It means you must solve all the problems your customers meet. For example, if your customer is a device maker, you will need to provide him all the runtime environment for them. Or if your customer is an IC vendor, you have to provide him not only the AI IP, but also all the firmwares and the developed tools for them. That's why Deep Mentor developed a total solution, we call it Diplo Macro, to satisfy all the customers' needs. How Deep Mentor achieve to make the cloud AI into the Edge AI? We do a miniaturization. What does miniaturization do? Miniaturization does low-bit computation. It means in the real case, we make the AI only compute in 4-bit operators. When we convert all the complex AI computation operator into 4-bit styles, we will reduce up to 90% data movement and the computation complexity. And we only lose 1% quality of result. I mean quality of result or quality of service. Okay. That's why we do about the quality of service. Without, you can see the upper and the lower situation. The upper is use our miniaturization technology, and the lower is use the quantization or pruning technology. The main difference is if you use our miniaturization technology, all the AI can keep the detailed feature still in the systems. But if you adopt the quantization or pruning technology, you will see your AI system will lose lots of details information. So you will get less information and less result. That's why we think the miniaturization technology is suited for convert the cloud AI into the edge AIs. So we start from talk with the many industrial leaders to do lots of POCs. First, we cooperate with Coral. Coral is Google's subsidiary company, and we use their chip to do the POC test. And the other, meanwhile, we also cooperate with the Israel's chip developer called Halo. We use their chip to build the POC test. We call it the AI Edge AI box. We use this to prove the concept of it's possible to convert the cloud AI into the edge AI in a very simple way. We do lots of POCs, and we learn lots of experience from this POC, and we based on these POCs, we develop develop makers, and the develop maker is a no-code SaaS system. It will help your user to reduce their development time and make them can maintain their AI system in a very easy way. So when a company wants to develop a new AI system, they do not need to hire lots of AI engineers. They only use our develop maker system, and they can achieve their purpose. And after we do these systems, many IC companies ask for us, can we convert their own private AI algorithm into the circuit for them? And so we, in our develop maker, we also add a code generator for HDL code. It means when you have an AI algorithm, you can use our develop maker's software SaaS to generate the HDL code, such as Verilog or VHDL, and to make your own chip in hardware circuit. That's the three products we developed in these 4 years. When we developed product, we found a very interesting result. First is because we use 4-bit computation unit. So we can use the 40 nanometers process to achieve the same as the 28 nanometers performance. It will save lots of money and time for your software development and chip development. And this is the final status we in status now. Because we develop develop maker SaaS systems, all our customers can use the 80% of the system directly, and only 20% of our customer need to modify. Without this system, we combine all the Taiwanese manufacturers together to make the AI developed in the edge system very easy. And this is our share. Thank you.
Thank you, the Mentor CEO, Jaku. And next up, Kudo is a VC-funded startup based in the United States with staff in more than 25 countries and clients in more than 30 countries. Kudo is a multilingual web conferencing platform with human-powered live and remote interpretation. So now please welcome the account executive team lead from Kudo, Arya Sternberg. Welcome.
Hello. 各位先生,各位大姐,各位小姐,大家好. I'm not going to speak Chinese. My name is Arya Sternberg. I am the account team lead for APAC for Kudo. And today we're going to talk about breaking language barriers. So Kudo helps businesses and organizations to hold meetings, events, webinars, and any sort of remote or hybrid activity in any language at any time, so everyone can be understood. We do that, where do I point this? Through interpretation. So we bring human interpreters together for our clients to take anything that you want to say and let anyone speak and show up in their native tongue. We've been working in this space since 2002, in the digital realm since 2015, supporting the United Nations, Microsoft, Meta, Facebook, and many other large multilateral organizations to do this. We have two key parts. One is the platform that allows us to enable the interpreters to join. The other part is our unique and exclusive 12,000 plus strong marketplace of interpreters. Over 200 languages, both spoken and sign language, are there to join and support you anytime, anywhere. We do this through automated booking on our marketplace. You can have interpreters for many languages in up to 2 hours instead of 2 weeks. This is automated and available for you online anytime. Why would you do this? You might have an event like this where the audience doesn't necessarily speak the language that you're presenting in. You may have board meetings, client meetings, sales meetings, workshops, training, company announcements. Anything or any time where you want to increase the opportunity for people to join your meetings, that's where Kudo comes to play. Increase sales, decrease costs, expand your brand presence, or most importantly, bring people together. It's very difficult to stand here and have a conversation with you if you can't understand what I'm saying. And if you want to tell me exactly in the words that you want to say, why not speak your own language? That's what we do. We do that as a software as a service. We're cloud-based, we have the highest levels of security available, and you can access us from anywhere. We have the Kudo platform, which is what we launched with back in 2017. We're natively integrated into Microsoft Teams. We're available on Zoom, WebEx, and every web conferencing platform. We're also available on every large event management platform, such as Hopin, On24, Hubilo, anything that you need us on. Our clients speak for themselves, from government organizations like the United Nations, NASA, Council of Europe, technology companies, Microsoft, Amazon, pharmaceutical, Pfizer. We've got industrial clients ranging from automotive, manufacturing, textiles, and food companies. Some logos you might recognize. One of my favorites is Ferrari, for example. Security is number one for us. We are ISO 27001 certified. We have every necessary security component available, so you can trust that everything that's passing through Kudo is secure, confidentially held, and held in privacy. We are GDPR certified, so you can work around the world. I could tell you how great Kudo is, but it's not up to me. We were awarded Time Magazine's Top 100 Best Inventions of 2021 for our marketplace. We've received other accolades, such as the one we have here today. And most importantly, we're here for you. So whether you're looking to save time, increase your efficiencies in your company, use the best technology available, and ensure that everyone that you're speaking with, meeting with, presenting to can understand what you're saying, we're here to make that happen. Thank you. 谢谢大家. 再见.
谢谢 Mr. Sternberg for your presentation. All right, next up, Q-Scar is a startup with 3 years of lifetime since founded, and the office is located in Santiago, Chile. And they developed a software solution called Quantum Interconnect Explorer, QIE, for the semiconductor industry. So now, please join me to welcome the CEO, Claudio Arenas. Welcome.
Hello, hello. Thank you for the opportunity to be here. It was a long trip from Chile, so it's nice to be here. My name, as said, is Claudio Arenas, and I'm the CEO of QSire. The story of our company is basically targeting the semiconductor industry, but with bridges in the academia, as you will see. In a chip, for example, you see that there are layers of transistors on bottom, and on top of them, there's multiple layers of wires, or interconnects, I might say. So there's a lot of effort understanding the behavior of the transistors, even at the atomic level, but in the wires, there's some missing gaps there. So with a group of colleagues, former members of Synopsys, we noticed those gaps, and we think about creating this company. So here's my team. Here I am, there I am. Almost all of us are former members of Synopsys. Xavi Vargas is my long pal from the university. And we receive a kind help from Anton Domik, former CTO of Synopsys, in order to help us to open some doors here and there. Starting from the foundation in 2019, we received some funding, around $2,000 from our local government and angel investors. And with that help, we're starting to reach some companies in the industry. I might mention, for example, ITRI Labs here in order to do some collaboration. Currently, we're working with Applied Materials and also with IMEC. So what is what we do, basically? Well, we basically take from science to the EDA industry. This is the cover of Applied Physics Reviews for the theory of calculating the resistance and the resistivity of metallic structures with nanometers in dimension, a few nanometers. And one of the goals of this publication was, for example, here you can see we adjust this value for a wire, and just by changing the dimensions of the wires, we predict the trend of the different tech nodes. That is something that is very expensive to know before our theory was created. Besides of that, we did some analysis on the influence of surface roughness in the same wires in a chip. And from there, we create the product called Quantum Interconnect Explorer. Basically, it's the accumulation of the knowledge of this theory into a product. What we can do with Quantum Interconnect Explorer? Basically, you can calculate the resistance or the resistivity of many metallic structures inside a chip. For example, you can do all of these kind of layers, or you can do simulations like this in order to see the influence of different processes into the actual parasitics of a chip. Besides of that, you get the Quantum Interconnect Explorer plus a C model, the capacitance model, in order to get the full RC values for your interconnects. And then you can see a sample of that. This kind of simulation takes like 20 seconds or so, something that is not currently available by other methods. Here you see a detailed version of the GDS2 to RC parasitics flow. This is an automated flow. You input the typical values for the industry, and then you just execute your script in order to calculate the resistance and capacitance of the whole cell in this case. As I mentioned, this one takes only 20 seconds. Take, for example, what happens if you want to calculate the same doing atomistic simulation. That would take forever in this case. And if you're trying to use, for example, mesh simulations or electromagnetics, you will need to use some parameters that need to be adjusted each and every time you change the process. All of these parameters, basically, we can predict the values of them. So it's a groundbreaking invention. That's my presentation. Thank you for your time.
Thank you, Claudio, and thank you for flying all the way from Chile. It's actually really a long flight. I hope you enjoy Taiwan. And now, next up, we're going to have Thai Award third place winner, Paragraph. And Paragraph was the first company to mass produce graphene-based next-generation semiconductor devices in 2019. So now please welcome the CCO, Tom Wilson from UK.
It's very good to meet you all. First of all, I'd just like to say that we're very honored to be here and somewhat proud, actually, to be third place and be the only non-Taiwan winner. So we're very proud of that and deeply honored. So let me talk a bit about Paragraph. So Paragraph is the first in the world to use graphene in the mass production of electronic components using standard semiconductor processes for a wide range of critically important global challenges. So that's a big sentence. In fact, it's what I hope you'll see at the end is it's a huge sentence in terms of the opportunity content in that sentence. And basically, it's the entire content of my presentation, so I can almost stop now and thank you. No, actually, I'll keep going. So I'll actually use the presentation to unpack that sentence just a little bit. So Paragraph was the first in the world to use graphene. Well, I'm going to spend the first part of the presentation talking about graphene and what makes it so special. The next part of that sentence was to use graphene in the mass production of electronic components with standard semiconductor processes. So I'm going to spend the next part of the presentation talking about why that's important. And the last part is for use in a wide range of globally critical challenges. So I'll spend the last part of the presentation talking about that. So graphene is actually the first of a new set of materials that were really set to transform electronics as we know it. It was really the dawn of advanced electronics materials. For those of you who aren't familiar with graphene, it was discovered in 2004 in Manchester, UK, and in 2010 there was a Nobel Prize awarded to the two men who discovered it. This illustration kind of depicts graphene fairly well. It's a two-dimensional, one atom thick sheet of carbon atoms that are arranged in a hexagonal array. And it, for some time, has been viewed as a miracle material because of a really interesting set of very special attributes. For example, it has super high conductivity, 1,000 times that of copper, which makes it actually really ideal for the next generation of transistors. You may be familiar with Moore's law, where the advantages we get of going deeper sub-micron have been flattening out over time. So graphene has the promise of rebooting Moore's law. It's optically transparent, which makes it ideal for use in some optoelectronic applications for optical switching. It's highly flexible and stretchable, which makes it amenable for a whole new set of bioelectronics. It's high strength, so we can make highly durable, extremely rugged displays and touchscreens. It's thermally stable and extremely thermally conductive for a new range of thermal management possibilities. It's chemically stable and biocompatible. That is immense, because this introduces a whole new horizon for biosensors and clinical diagnostics that are now faster, less expensive, and more available to more people, saving more lives. So it's not surprising that the world has been holding its breath for some time to be able to take full advantage of this miracle kind of material. But the challenge has been able to mass produce graphene in electronics with standard semiconductor processes. So Paragraph has actually done that. Paragraph has made graphene an industry-ready solution. In order to do that, it was important to make this manufacturing process repeatable, to be able to do it over and over and over again in mass production, and ensure that the purity, the 2D graphene that is deposited on the wafer substrate is contaminant-free. And do that in a way that is industry standard so that it's integratable. We can integrate it into standard manufacturing processes. So going from graphene production to graphene processing to actual graphene devices has been done. So Paragraph has made it possible for wafer scale mass production of graphene devices. This means that now we can really realize the promise of graphene. We can begin to apply graphene to some really critical global challenges, and that's the last part of that sentence. So we have global power consumption issues, an exponential growth, for example, in the energy consumption of data centers. Graphene can increase compute power by about 100 times at half the power. The world's biggest killer diseases are time sensitive. They move quickly. Graphene-based biosensors for clinical diagnosis makes diagnosis much faster, much more cost-effective, and democratizes clinical diagnosis. Data access throttles learning. It's a bottleneck to learning and information exchange. Graphene can make it possible to bring to bear terahertz broadband to resolve that. So, with the world's first integratable, scalable graphene mass production capability, the revolution in advanced materials electronics has begun, and Paragraph is leading the way. So if you would like to learn more, we have our booth just over there, so feel free to come see us. Thank you.
Thank you, Mr. Tom Wilson, for the presentation. And next up, we will have Flowview Tech, our second place winner, a spin-off from E3 in 2017, and has dedicated itself to developing high-resolution liquid sample inspection technologies that produce faster and more accurate results. And now please join me to welcome Kyle Lee, the CEO of Flowview Tech. Welcome, Kyle.
Okay, hi. Everyone, I'm Kyle from Flowview Tech. Today, I'm very happy to give a presentation here and also introduce our company. Flowview is a solution provider for liquid-borne microcontamination analytics. So our company spun off from E3 2017. So I think many people want to connect with E3 from your presentation. So we have a very strong connection with them. So actually, we can help. So we provide very innovative flow AOI technology. AOI means automatic optical inspection technology. And we specifically focus on wet processing and also help our customers to inspect the fluid, including water and even chemicals. So till now, we already got the investment from a very famous company like Sumitomo Corporation in Japan and NDF from Taiwan government. So we keep working very closely with our strong shareholders to develop the business globally. So our inspection technology can help our customers to improve the quality and also the efficiency. And more importantly, you can realize circular economy and even ESG are very popular topics recently. We can also help our customers to do that because we can provide our inspection technology to do more material recycling and even help them to save more water and even energy with our technology. So our solution can be applied for not only R&D lab, but also for the inline monitoring. So we help our customers to do more material analysis and failure analysis with our technology. Eventually, we will also extend our market not only for the process line, but even for the wastewater, because we got more orders and even customer requests from the, the water analysis requirements. So our technology can be categorized into 3 parts. We develop our technology based on microfluidic system. So we develop very innovative in situ flow microfluidics chips, and even work with our microflow system. And eventually, we will introduce our technology to work with AI technology to do more image processing. So now we already commercialize our product and also apply for different fields. Of course, semiconductor will be our main focus. So you can see the picture to know more our equipments and products. So our products has been adopted by very leading semiconductor manufacturers. So to help them to monitor their microcontamination from the water, resin process, and even chemical processes. So with adopting our technology, we already can help our customers to save over 70% material and even labor costs. So we provide a very complete solution portfolio from the R&D side to process line and even the wastewater. So eventually we will integrate all the data into our process diagnosis platform to help our customers to even predict the defects from their process line. So we are working closely with key accounts from this presentation. So we work very closely with them to generate more use cases. So till now, we are now working with the key customers in Taiwan, but also extend our market globally. So we are working with some very leading strategic partners to develop more advanced equipments and also apply for semiconductor industry. We are also working on with our partners to develop the demo size in Taiwan, Japan, even Korea. Those are very important semiconductor manufacturing companies. Yeah, thank you very much for your time to understand our company. We will be very happy to work with them to help you foresee the future of fluid flow view. Thank you very much.
Thank you, Kyle, for the presentation. And now it's time to meet our first place winner, Gassing Technology. Gassing was spun off from National Taiwan University in 2018. And Professor John's team created an elegant eye tracking technology with state-of-the-art performance. And then decided to start up the eye tracking company targeting on AR, VR market. So now, ladies and gentlemen, please welcome the CEO and founder, Professor Shao Yijian.
Hello, everyone. My name is Shao Yi. I'm the founder and CEO of Gassing Technology. First, it's our great pleasure to get the first prize among all these strong competitors. Gassing Technology is an eye tracking solution provider. Our vision is to create the most practical and easy to use eye tracking solution for everyone. Eye tracking is a technology that can know where you are looking at, and it has been approved to be a useful tool in research and assistive technology. Wait a minute. Okay. And the market size is around 500 million in 2019. Combining eye tracking and the trend of the metaverse will give us more new opportunities. Okay. First of all, when the display coming closer to your eyes, and the traditional user interface, for example, the mouse and touch screen, will become not applicable anytime. So instead, we will use the gaze eye tracking with the gaze control and voice control will become the mainstream in the metaverse. And eye tracking can support hands-free interaction, especially for the scenarios of smart manufacturing and medical research. And eye tracking can bring the location-based service to the next level, what we call attention-based service. Imagine that in the near future, your smart glass can reply to your question according to your attention. Last but not least, in VR, with a technology called the full-field rendering, eye tracking can help save more than 10 times of the power consumption and computation. So that's why eye tracking will become the building component in all AR, VR devices. And the market size is 40 million shipments in 2025. However, the existing mainstream eye tracking solution is based on green refraction. It will require to put more than 10 LED in front of each eye. It's way too complex, leading high cost and not fit to the compact devices such as Pancake VR, AR, and smart glasses. Instead of the complex solution, Gensing's Aurora solutions only need one sensor and one LED per eye. And it is not only highly flexible, but also has a much lower BOM cost. So the secret behind is that the Gensing's eye tracking solution is based on the AI technology. So we can derive the 3D gaze simply with only with the eye images. So we also collect a large and diverse eye database and to improve and verify our algorithm. Now, our eye tracking solution can achieve the same level of accuracy and robustness just as other mainstream eye tracking solutions, but with much lower cost. So there are several features of eye tracking solutions. First is the AI-based algorithm optimized on Qualcomm platform. Second, it has the simplest component configuration. Third, it can support all kinds of AR, VR devices with one single solution. Okay. And to further reduce the power, the computation for the target platforms, we even designed the ASIC chip for our eye tracking. So our first generation chip won the Innovation Award in CES 2020, and we will tape out our second generation very soon. Okay, in these years, we formed deep collaboration with AR, VR ecosystem partners. For example, we have been working with Qualcomm for many years, and we enable eye tracking capability in many of our Qualcomm platforms. And Epson is also our official eye tracking partners. And one of the successful cases is Georgian J7EF case. It's just won the Computex this year. Okay. The reason why we can achieve this is because of the strong team. We have a strong team. It's integrated of a young talent and experienced leadership. And we also have a strong advisor and board member, including the VP of HiMax and the director of Wistron, and the Dean of NTU D School, and the former Minister of Science and Technology, Professor Liang Jichen. We are Gensing Technology. So thanks for listening, and welcome to our booth in TIE. Thank you.
Thank you, Professor Jian. And Gensing is the first place of this year's TIE Awards. Thank you. Please kindly return to your seats. And that's all the winners for TIE Awards 2022. So, ladies and gentlemen, please give a big round of applause again to congrats all of the winners. I know some of you just flew all the way to Taiwan for this award. Thank you for coming. And if you're interested in any of the teams, please visit their booth. Their booth is just around the corner. Maybe you can talk to each other for further cooperations in the future. And thank you so much for joining us today. The official award ceremony will be held on the 15th of October right here. So maybe you can join again. Thank you so much for coming, and please visit their booth. I'll see you later. Thank you. 各位贵宾，大家好！我们国科会的大家长吴正中主任委员以及贵宾们，现在已经莅临现场，我们掌声欢迎主委。Ladies and gentlemen, please welcome the Minister of National Science and Technology Council, 郑中吴。主委好。Minister Wu, distinguished guests, ladies and gentlemen, welcome to the opening ceremony of FUTEX 2022. I'm your MC today. My name is Rebecca. FUTEX is organized by National Science and Technology Council, NSTC, along with Academia Sinica, Ministry of Education, and Ministry of Health and Welfare. And this year, FUTEX features the theme of Global Tech and Industry Tie with Taiwan. And NSTC promotes two strategies, inbound and outbound. Inbound is to attract overseas talents to come to Taiwan. And outbound is to send Taiwan high-quality teams abroad. And with that, in order to lead Taiwan's innovation and technology to be shine on the global stage. So in the very beginning of our opening ceremony, I would like to welcome the Minister of National Science and Technology Council, Minister Wu Zhenzhong, to give us an opening remark. 我们一起掌声欢迎国科会的吴正中主任委员来为我们做开场致辞。我们欢迎吴主委。
Our keynote speakers, Mr. Campbell from Qualcomm, and also keynote speaker Webman from Chain Reactions, and also TIE Award nominees, and distinguished speakers and guests. Ladies and gentlemen, good afternoon. Welcome to Taiwan, and also welcome to Future Techs. On behalf of the National Science and Technology Council, I would like to thank everyone that make this event happen. The timing of this year's Future Tech is perfect. As the pandemic began to ease off, actually it's today, we can now talk in person about how technology will solve the next wave of global challenges. NSTC is proud to hold this first ever Tech Innovation Excellence Award, we call TIE Award, which features breakthroughs in AI and IoT to smart manufacturing and autonomous vehicles. Most importantly, this award supports the people that support innovation. Throughout the COVID-19 pandemic, Taiwan produced semiconductors that keep the world running. Our actions have shown that Taiwan is resilient, reliable, and responsive. In the future, we will remain a powerhouse in semiconductors while leading the way in exciting new sectors such as green energy, precision health, cybersecurity, etc. In other words, we will keep making the best chips for today, and also along the way, we develop the game-changing tech of tomorrow. Today's event marks an important step in that direction. At Future Techs, we have representatives from Qualcomm and also promising startups such as Chain Reactions, Mr. Wellman over here, also here. And also we have world-renowned Taiwanese corporations, Macronics, Wanhong Dianzi, and also Realtek, 瑞昱半导体, as well as Taiwan's top academic and research institutes. As we embark on this journey together, government agencies like NSTC and also MOEA and also Agricultural Council, etc., will be the engine that keeps everyone moving forward. Once again, thanks for taking your precious time to be here today. I wish you all the best in the future. Thank you.
Thank you， 主委，我们请主委先帮我们留步舞台上，不好意思，接下来我们要邀请贵宾们到舞台上来进行一张大合影。Now we'd like to welcome the guests of honors to be on stage to join us for a group photo. 那首先呢，我们要邀请的是共同策划我们未来科技馆展出的跨部会单位，我们欢迎卫福部刘明勋技监，以及中研院吴汉忠主任。同时也欢迎教育部的柯金卫副司长。那接下来呢，要邀请的是接下来马上要登场半导体论坛的主讲嘉宾。Now we'd like to welcome our keynote speakers to be on stage. 我们欢迎美国高通工程部门的资深副总裁 Mr. Michael Campbell, the Senior Vice President of the Engineering Department at Qualcomm Technologies, 以及以色列 Chain Reaction 共同创办人兼执行长 Mr. Alon Webman, the co-founder and CEO at Chain Reaction. 接着我们欢迎旺宏电子卢志远总经理，以及阳明交大产学创新研究院孙元成院长。接着我们欢迎瑞昱半导体发言人暨策略与事业拓展黄一伟副总。好，我们请贵宾们帮我们到舞台上来。那工作人员呢会拿出我们的手拿板。那也请大家呢可以帮我们拿着手拿板。今天呢非常难得有来自海内外的贵宾参与。那稍后麻烦各位贵宾帮我们拍照的时候呢，将这个手拿板稍微向下压一点点，因为会有一些反光，就是对。然后如果方便的话，可以帮我们将口罩摘下。Now you may take off your mask if you feel comfortable for the photo shoot only. Okay, now please take a look at that camera in the center. Our photographer in the center first, like 3, 2, 1. Please smile. Thank you for joining us at the FUTEX 2022 opening ceremony. Okay, can you have your thumbs up? Okay, all right. Please have your thumbs up and look at the camera in the center again. Global tech and industry tie with Taiwan. 好，那我们请舞台上贵宾帮我们留步。Please remain on stage. We're going to invite more honorable guests to join us on stage. 接下来我们邀请我们这个推动科研成果的背后推手，我们国科会林敏聪副主委。 以及国科会陈宗全副主委。接下来欢迎国科会林广宏主秘，以及产学处的许增如处长。接着欢迎自然处罗梦凡处长，纵规处彭立春处长，以及工程处李志鹏处长。接着我们欢迎生科处陈昭荣代理处长，以及人文处林明仁处长。接着我们也欢迎科国处叶志成处长，以及前瞻处蔡妙慈副处长。紧接着我们欢迎竹科管理局王永壮局长，还有南科管理局苏振刚局长。接着我们欢迎中科管理局的施文芳副局长。那我们也请贵宾们，如果方便的话，可以将口罩先摘下。And once again, if you feel okay, please take off your mask. 好，谢谢。好，那我们一样先看一下中间的摄影师。Please look at the camera in the center first. Okay, 3, 2, 1, smile. Okay, please have your thumbs up. 好，我们第二排的长官可能要自己稍微呢，这个帮我们看一下，然后向中间点点集中，然后加油的手势是不是 ？OK， 第一排好，我想我们的2位 keynote speaker 在想说，好，台湾拍照有很多很可爱的手势，等一下就要请他们比小爱心。然后我们看一下中间摄影师 ，Please look at the camera in the center. All right, 2022 Future Tech. 我们 OK 了吗？中间的我们的官方摄影师有拍到了画面。好，谢谢 ，Thank you。我们谢谢舞台上的贵宾，那我们也请主委可以先回座，谢谢。那接下来呢，我们也请舞台上的贵宾可以先回座。Now please kindly take your seats. Thank you。我们也请贵宾们帮我们小心脚步，请留意我们的阶梯，谢谢。Please mind your step. While returning to your seats, thank you so much. And now we will proceed to the opening keynote speech. Ahead of the trend, the global market for semiconductor in the next decade. And now we'd like to welcome the moderator, news anchor and program host in technology, finance, and economics, Ms. Ashley Chu. Welcome.
Thanks, Rebecca. Chief speakers and distinguished guests and ladies and gentlemen, welcome to the forum. It's my honor to be the forum moderator today, and I'd like to introduce the first keynote speech. As we know, Qualcomm is the world's leader in CDMA manufacturing and wireless technology, and also Qualcomm is the top 2 mobile phone IC design houses. And as the market of EV will grow in the future, we see that one day Qualcomm will also become one of the most important companies in the semiconductor industry. So what's the Qualcomm's strategy for the future? Now let's welcome Michael Campbell, Senior Vice President of the Engineering Department of Qualcomm, to give us the speech. Please give him a round of applause.
Good afternoon. Thank you for having me, Mr. Wu. It's my honor to be here, sir. I have been coming to Taiwan now for approximately 25 years. Not all with Qualcomm, other companies. And I have always been amazed at the innovation, the spirit, and the beauty of this country. So the spirit of the beauty and the innovation of this country is always shown. I want to talk about the endless opportunities that are available with the advancing technologies that Taiwan is helping bring to market. COVID in the last 3 years really has taught us all that digital technology, digital communications is critical. Many people around the world only worked from home over the last 3 years. That was only possible with advanced technologies and secure networks. If you look at this, you can see that the transportation industry is transforming, the energy industry is transforming, health, human services, smart cities, and energy. All these industries are changing the world as we know it. The 5G networks that are available in many cities today can communicate to a private 5G network where factories can run autonomously. And those autonomous factories can either go lights out or they can be run by very few people and just a few robots. In ASE, a company, a partner of ours in Kaohsiung, they have a 5G factory. That factory is standalone, but the internal communications are run off of 5G technology. That is an innovative use of the technology and how we can bring different changes to the world and still have excellent use of manufacturing. The automobile is what I'm going to center on for a few minutes here. The automobile is one of the key factors in the changing industry. Automobiles went from having a couple hundred, maybe, dollars of IC content in them to having thousands, if not multiple thousands of dollars of IC content in them. As we go to Teslas, as we go to BMWs, as we go to Porsche, EV cars, the content of a car can go up to $5,000 of semiconductors in that car. Taiwan produces well over 60% of those semiconductors, and that makes it a critical part of the global supply chain. 5G is a way, especially for cars traveling down the road, to become autonomous. Cars need to have automatic feedback from the vehicles around them and from the industry and for the local areas. With 5G technology, that communication lag goes to almost zero, and the car can react almost instantaneously to changes in the environment, changes in the road, or changes to cars around it. In this very simple example, a car or anything talks to an individual device. Oops, it doesn't. Okay. Talks to a device. That on-device has to have AI technology built into it. So the faster we can process through the CPUs, the more powerful our AI engine is, the more we can do on the device. But the device needs to talk to the outside world. 5G allows it to talk to the edge of the cloud, and then the edge of the cloud can be hardwired into the big cloud. But for instantaneous communication, you need the ability to go from the device to the edge of the network and back again. The car is, again, the center of the piece. As you know, Qualcomm has recently announced that we've got a $30 billion pipeline of advanced process technology, most of it coming from key industries here in Taiwan. Those new cars provide digital services, smart transportation, immersive entertainment. My wife's new car has 6 touch screens in it. I don't know why any car needs 6 touch screens, but it has it. It would be perfect, I guess, for my godchildren, but okay. That immersive infotainment allows you to have 6 different streams of programming. It allows you to make data calls, touch calls, to gaming while you're driving down the road. That kind of data information changes requires high speed, low latency data communications across the globe. Each one of those cars that is partially autonomous these days has a fairly large AI engine in it. The AI engine has to make the decisions on the fly from edge network data and from data from around it, surrounded by the cars. We at Qualcomm and many other companies here in the exhibits are partnering together to bring that technology to your car, to your washing machine, and to your universities. In the near future, by 2035, an industry study predicted that there would be a $13 trillion electronic pipeline. That pipeline is going to be headlined by the healthcare changes, smart cities, industrial, agricultural, manufacturing, automotive, retail, energy, and et cetera. Those changes, those industries have to grow significantly to have a $13 trillion pipeline that's enabled. My favorite thing, as I grew up on a farm, this picture of the farm being harvested by multiple combines with no operators on board, being driven by 5G technology, AI engines so they can know where each other are, is an amazing feat to improve the productivity of farms and allow crops to come to market regardless of the ability of workers to get to the field. That $13 trillion pipeline of electronics is a challenge for the entire industry to surmount. That challenge will bring change. Change is the necessary engine for innovation and for growth as we go forward into the industry. A study by McKinsey showed that the semiconductor industry will grow to $1 trillion by approximately 2030. In 2021, the size of the semiconductor worldwide industry was $500 billion. So in the next 8 years now, we have to double the size of the industry. If you think about what that means double the number of semiconductor fabs, double the number of assembly companies that we have to build those fabs, double the amount of transportation we have to use to get those semiconductors to market, double the number of IDMs that have to bring that semiconductor to market. As you can see, automotive is the largest percentage gain in electronics. We've already talked about why. Putting an AI engine in there, putting large microprocessors in it, really drive significant growth in the semiconductor content. But that's a small potato compared to compute and wireless. The wireless industry will continue to grow somewhere around 25% by that time period. Compute will grow and is the largest powered sector by that market, especially high-powered compute. This is a partial, please remember that, partial map of the semiconductor supply chain. This incomplete list still gives you a very clear view of just how global the supply chain is. From Japan to Taiwan to China to Korea to the United States to France, Germany, Spain, Italy, Israel, the semiconductor supply chain populates the globe. And as it continues to populate the globe, changes in economics around the world are sitting to say, we want a factory here to have some balancing to the supply chain. That's fine. When we're going to double the industry, we have the ability to put a factory almost everywhere if we're really going to double this industry. What are we going to double the industry with? A few years ago, in 28 nanometers, most technology was planar technology. Planar technology can be explained by seeing the source that's labeled there. Can I highlight this? No. By seeing the source there, it was buried in the substrate. That limited the amount of voltage and the ability to control that voltage in the semiconductor. In 2011, we went to FinFETs. As we raised the source out of the fin, out of the substrate, we increased our ability to control the voltage. That allowed us to lower the voltage, lower the power required by the semiconductor, and make better use of the silicon area that we had. By 2020, in 2024, we're going to start seeing gate-all-around semiconductors. What gate-all-around does is put a ribbon of nanowires through the gate. Those ribbons of nanowires will be then better controlled. We can again lower the voltage significantly in the semiconductor, thus making the semiconductors even more efficient in the industry. There's two paths to get there. One is called device technology co-optimization. That's where we just continue to make the devices smaller. The other path is the more exciting path in many ways. It is really the 3D IC path. As we start stacking chips on top of chips, memory on top of logic, 3D memory on top of logic, backside power grids so we can control the power more effectively, and finally getting to chiplets, which companies like AMD are using today. That allows us to make better yield, more effective use of the silicon, and again, bring better products to our consuming public. 3D ICs are complicated, they're confusing, and they're a little bit magical to me still. But if you look at it, you bring a die into the bumping factory, and you basically stack 2 die on top of each other. That's the easy part of it. When you bring it in, but you start drilling holes through the silicon, it's called bringing a through silicon via. If you do woodworking, that's like taking your drill press and bringing a hole through the drill press and being able to touch the board below it. It's a lot more complicated than that in silicon, but that's the general concept. Again, you can bump that silicon, put the multiple die together, and in the packaging factories, the OSATs, we can put the final product together and deliver it to the customers. These are very complicated technologies, but this is what's required to take the next generation use of Moore's Law. Moore's Law basically stated that every 18 months, the amount of silicon the amount of transistors per millimeter squared would double. With standard shrinking technologies on just the die shrinking path, we're running out of steam. However, Moore's Law never said anything about not cheating. So by stacking die on top of die, we actually double the number of transistors per millimeter squared as you look at it by an XY construct. In 2035 or thereabouts, we're going to start tracking transistors on top of each other and truly do double the transistors in the same amount of area. But we have to practice to get there. It's going to be a long, complicated, complicated process where we're going to need the brightest minds, the smartest people to be able to drive that new technology. Taiwan has again and again shown it has the technology, it has the universities, it has the brain power to bring the new technologies to marketplace. I look forward to seeing Taiwan bring this to market and really being able to drive this technology for us, the semiconductor user. This just gives you a quick view of what's happening. Stacking a package on package is easy. Putting an interposer in there is also relatively easy in terms of today's technology. When we start to doing 3D ICs of interposers or with through silicon vias in place, it gets a lot more complicated. When we start doing wafer-to-wafer bonding, yet again more complicated. And finally, when we get to 3D stacking by about 2035, 2040, it's going to be mind melding because it's very, very different technology. So I want to just say the semiconductor and Qualcomm are committed to Taiwan. The global semiconductor supply chain will continue to add value to this entire marketplace. You saw it trying to drive a $13 trillion market by 2035. Efforts are underway globally to grow the breadth of the supply chain, but if the industry is going to have to double anyway, where those factories go, doesn't matter. The technology that Taiwan develops will go to those factories because someone has to be first, and Taiwan is the most likely candidate to be first. The world needs a highly educated workforce, a very innovative workforce to bring these technologies to bear. I can say nothing but very positive things about your university, considering the number of people we've hired in the last few years here in Taiwan. They are amazing in terms of what they learn and how fast they come up to speed in terms of learning new technology from us. In Taiwan, we have built innovation centers. There's a booth back that way someplace with one of our innovation centers back there. Please stop by. And look at what the innovations are bringing. I believe the winner this year is building hearing aids, very small hearing aids with Qualcomm technology. So something that's easy, simple, but very useful to the world around you. Qualcomm will again continue to recruit and drive technology here in Taiwan. We, the semiconductor industry, however, need access to water and power. We're more than willing to help with power plants and et cetera, but we need that access. And you've been excellent in supporting the industry here. But as we grow the more factories, it's going to become more difficult. And we all have to find better ways to bring green energy to the marketplace so that we can use those factories, but use them with green power and then continue to not pollute the earth around us. You've seen from most of the factories here in Taiwan, they're doing basically 100% recycled water. That recycled water keeps the groundwater from being polluted and keeps the total utilization of the factory down. But even those factories need to be able to reclaim some new water because steam just escapes somewhere from someplace. Taiwan is a key member of the Qualcomm supply chain. Thank you very much for being a key member. Come on. Taiwan is, basically in closing, Taiwan is a key member of our supply chain, and you're very well positioned to remain a pivotal portion of that supply chain globally as we move worldwide. That's the end of my speech. Thank you very much for having me.
Thanks to Mr. Campbell to give us wonderful speech. Thanks. And really, thanks to Qualcomm's commitment to Taiwan. Thank you. Yes, we are turning into a new era, not only because of the growth of the EV market, AI, 5G, or 3D IC, but also because of the blockchain. Blockchain has become a really hot issue recently, which is one of a growth momentum of semiconductor industry. But how can we ensure information security and at the same time determine the scaling of chip production? Now let's welcome the co-founder and the CEO of Chain Reaction, Alon Webman.
Thank you, everyone. Good afternoon. Thank you, Mike, for a great speech. There's a lot of subjects that we will cover together. I would like to talk today about engineering semiconductor for the future of privacy. In today's world, it's all about data and data processing, where data, the amount of data increases exponentially. Having data is not enough. It's all about what you do with it. That's what really matters. For data to be valuable, it has to be processed in real time. Just like it's not relevant if you get the news of last week. Same goes to data. And by the way, there is a good example of real-time processing, which is the AI that is translate my speech. I will ask you after that if you did a good job. And let's talk about data processing. Big data processing is a set of techniques to access large data scale and extract useful information for decision making. Big data is often characterized by the 3 big V: large volume of data, wide variety of data types, and the velocity of where we generated data, collect it, and process it. The goal is obtaining real-time actionable insight that are driving core competitive advantage and a better decision-making in organizations. This allows them to win opportunities, to be the best, and to be the first to market. It's all about time to value and time to market. Hi, everyone. I'm Alon Webman, CEO and co-founder of Chain Reaction. Chain Reaction is a semiconductor company that accelerates data in real time in data centers and cloud. And we design high speed, high performance, low power compute product for the next generation of privacy tech. And I would like to talk for the next few minutes about private data, what it is, what are the challenges, and what is the next technology leap that is required in order to overcome all of those issues. And why private data is so important? Because our privacy makes a difference for us. We want a medical record to be private. We want a financial transaction and our shopping habits to be private. As an individual, we want to control our data. Businesses rely on privacy for the competitive advantage, from oil and gas application to manufacturing to automobile to cell phone design. Private data is the 21st century most valuable resource. Government rely on privacy for everything, from science, from exploration, research, from everything about the privacy. And securing the data today is not enough, because we need to think about the future, when the quantum era will be here, and quantum machine will be able to get to anywhere and break to everything, almost everything. But I want to focus about today. A second. To be competitive, businesses must lead product innovation, deliver value and time to value and performance to their customer. Why? Because they want to be the first. They want to be better than the competition. They want to be the first to market. But they must continuously modernize in operation their services and the compute infrastructure, from system and workload to support it all. Otherwise, they will fail. However, not all of the business can afford to build a specialized on-premise advanced data centers. What we learned from COVID-19 is the economics of lease versus buy. Businesses still need accessibility and availability of the best compute, unlimited resources, and the most advanced technology, and this is what we find in the cloud. And this is why businesses are migrating to the cloud all the time. And as businesses are moving the operation to the cloud, it became a $500 billion industry. As more legacy data centers are moving their workload, the industry is growing 22% CAGR year to year. However, there are three problems currently facing the future modernized compute of the cloud. And I would like to talk to them about them in the next few minutes. The first one is the cloud is untrusted. We know how to secure data and to protect it on-premise, but when we migrate it into the cloud, it is not secured. And why is that? Because while we're doing the computation and the data processing, we need to bring the data, we need to decrypt it, do the processing, computation, services, encrypt it, and store it. While the data is being on the data processing and computation, our private data is plain text, visible and accessible to be stolen by malicious users. And this is this side of the slide, the left side. I will talk about the right side in the next few minutes. The second problem is energy cost that rises. We are in the middle of a global energy crisis. But regardless, as you can see from the table, from 2015 to 2021, data center energy demands doubled or maybe quadrupled. And for example, a mid-size data center for financial or governmental that used to cost $40 million a year, now the prices are double. And it's not going to get better. The huge OPEX and huge CAPEX are the fuel that trends the migration to the cloud. There's data centers that have energy cost higher than entire countries. But what we need to remember that for cloud services to be good, they still have to be cost effective. And that brings me to the next problem, the need for speed. As compute becomes more complicated and involve more data, the acceleration requires increase dramatically. CPUs and GPUs can only maybe achieve 200x acceleration. If I'll take a regular generic CPU that can do simple operation like subtraction, addition, multiplication, division, and take it as a 1x acceleration as a base slide, if we go to CPU and GPU, we can do more complicated calculation like linear regression. If in a system level, when you have optimized software and storage, memory, and networking, they can do AI, they can do deep learning, they can do machine learning. But if you go to the extreme complex compute that is required for privacy-enhanced technology, from zero-knowledge proof, fully homomorphic encryption, and cryptography, that is required to enable to do operation on top of encrypted data, this is not suffice. What we need is a really novel technology. And now that I talked about the problem, I would like to talk about the solution and break it down one by one. For securing the cloud, what's required is first, trusted environment that keep the data private and secure all the time. The 1 million time acceleration is required for real-time compute. Energy efficient solution, this is the only one that will be able to be deployed in the cloud at scale. And we in Chain Reaction want to do it all. We want to revolutionize the access to private data for the biggest global industry. Help the seller sell more by enabling big data analytics, AI, machine learning, deep learning, and of course, privacy-enhanced securities. And this is the holy grail of the cloud. Once the cloud is secure, the most valuable industries and enterprise can move to the cloud. Big pharma, medical, financial institution, and government, all of them want to transform the big data into knowledge, value, and insight, as you can see here. And this is where the Holy Grail is. Transforming an untrusted environment to a trusted environment. This is the next disruptive technologies of the future and the cloud. And everyone wants to be first. Intel, Microsoft, Google, IBM, Meta. Privacy in the cloud means that this $500 billion industry can reach 2 to 3 trillion by more and more applications moving into the cloud. And now I want to go back to this slide and talk about the solution and how it's going to look in the future of cloud and privacy. We have secured endpoint. They can encrypt the data. They move the data into the cloud. The data is encrypted and therefore secure. Now, with the private enhanced technologies, you can compute, you can do data processing and services on top of the encrypted data. The result is still secured. You move the result into the trusted zone, decrypt it, and here, this is the solution, and this is how the future of cloud and privacy will look. So now that we know how the future will look, and we know what the hurdles to get there, what we need is a specified solution to accelerate privacy-enhanced technologies. With a dedicated hardware, Chain Reactor private processor can reach more than 10,000x the performance of a regular server and with optimized software more than 100,000 times. And by that, enabling customers to move their businesses and private data into the cloud, and by that, solving the cloud industry biggest bottleneck. And I want to talk about the last piece of the puzzle. As a CEO, my job is to look at market's problem and to find and design solution that doesn't exist. But we can't do it alone. Neither can Intel, NVIDIA, AMD, Qualcomm. We can envision the needs of the future people and businesses, and we can design the product, but without partnering with the best-in-class semiconductor players of the market, our dream cannot become reality. And here in Taiwan, this is where our supply chain, our manufacturing, our fabrication, and our system design. This is the art of the state-of-the-art fab and processes with the knowledge of high-volume manufacturing, with the general availability in mind, with the expertise for low power and high performance product. We rely on our partners' expertise. And it's also personal for me to be here, to convey my gratitude, to be able to collaborate and partner with a country and an industry that's been spearheading the semiconductor industry for decades. We can't do it without you. TSMC, the #1 fab in the world, the best OSAT companies like ASC, the best ODM, OEM, and contract manufacturer like Gigabyte and Quanta. You are helping us making the impossible possible. You are helping us be the best, and we're changing the world together. And I'm honored and privileged to be invited to speak in this distinguished event. Thank you, Minister Hu, for hosting me so graciously. We are excited to collaborate with Taiwan's biggest industry leader and to disrupt privacy and many other industries in the future. I want to say that the support that Taiwan extended on us, on Israel, and chain reaction specifically, is so meaningful and profound. Our success is only possible thanks to you. Thank you, and thank you everyone for your time this afternoon.
Thank you, Mr. Alon Webman, for your wonderful keynote speech. Thank you. And please kindly return to your seats. Thank you. And now I would like to ask all of you, please give a big round of applause to two of our keynote speakers. Thank you so much. Thank you, Mr. Campbell. And thank you, Mr. Webman again. Thank you for joining us today at the opening ceremony of the 2022 FUTEX and giving us two very fruitful keynote speech. And right now, we will proceed to the panel discussion. And meanwhile, please kindly take your cell phone and scan the QR code showing on the screen right now. And please fill in the survey and enter the lucky draw. We can and also invite you to join the lucky draw at the reception area after today's forum. And right now, we will directly proceed to the keynote speech. to the panel discussion. So right now, I would like to welcome the moderator and panelists to be on stage. First of all, I would like to welcome the moderator, news anchor and program host in technology and finance and economics, Ms. Ashley Chu, to be on stage again. And also, I would like to welcome the panelists. Please welcome the Dean of the Industry Academia Innovation School of National Yangming Jiao Tong University, Jackson. Please be on stage to join us for the panel discussion. And also I would like to welcome Zhiyuan Lu, the president of Macronics and chairman of Ardentech. Ardentech, please be on stage. And also I would like to welcome Yiwei Huang, Realtek spokesperson and vice president of strategy and business development. And I would like to welcome Zhipeng Li, the head of Department of Engineering and Technologies of National Science and Technology Council. And right now, last but not least, we have one panelist joining us online, the professor of the Department of Electrical Engineering and Graduate Institute of Photonics and Optoelectronics of National Taiwan University, Professor Zhi Wu, who will be joining us online right now. Professor Wu, are you with us? Okay, I think Professor Wu will join us later. Oh, okay, I can see Professor Wu right now. So now I will hand over the floor to the moderator, Ashley.
Thanks, Rebecca. And thanks to all our 5 speakers coming today to the panel discussion. Today we will discuss about the future of the semiconductor industry. I think that everyone cares about this issue. So let's go straight to the topic. We see that recently a lot of news around the semiconductor industry right now. In fact, the development of the global semiconductor industry is currently affected by various factors. In terms of the overall environment, there is the US and China conflict and the geopolitics. A lot of countries wanting to build their own wafer fabric plants like a Neutron. And besides, we see that the United States has promoted the CHIPS Act, causing tremendous impact to the semiconductor industry. Last but not least, whether Moore's law will continue is also in questions. Everyone tries hard to overcome the physical limitations, seeking breakthrough by 3D IC and advanced packaging. So what's the future of the semiconductor industry? Would I like to invite 5 speakers to share with us under these internal and external challenges. What are the top priorities for Taiwan's semiconductor industry to maintain its advantages? And how can we establish our industrial competitiveness in the next decade? So I would like to first ask Mr. Zhipeng Li, head of Department of Engineering and Technology, National Science and Technology Council.
Okay, thanks for the moderator. In my opinion, in order to remain a leader of the semiconductor industry in the world, Taiwan must invest in R&D on critical technologies, search for new materials and testing methods, and cultivate outstanding talents in various fields, such as physics, chemistry, materials, and microelectronics and the instrument technologies. In particular, we have to pay special attention to the emerging technologies for the next decade semiconductor industry. For example, 3D packaging, 2D materials, quantum computing, and silicon photonics, computing memory, and etc. In addition, because Taiwan leads in the semiconductor manufacturing, especially in the capability of advanced manufacturing and supply chain integrity, we believe Taiwan semiconductor industry should take the advantage of its superiority to develop vertical integration and cross-domain horizontal cooperation. In conclusion, as long as we can keep developing innovative technologies, cultivating outstanding talents, and improving the efficiency of the supply chain, we believe Taiwan semiconductor industry can keep in the leading role of the and to maintain the worldwide competitiveness. Thank you.
Thanks to Mr. Lei's opinion. And how about Vice President Yi Wei-Huan? What's your opinion to this issue?
Yeah, thank you. Well, first, I'd like to thank the invitation here. It's really an honor here to share with you my thought. To answer how we can maintain the success, I think it's very important first we ask, how did we get here? Now, what was the reason that, what have we done that we have success today? My observation, really, this is a multi-dimensional answer. Start with, many people will say, Taiwan, geographically, a very compact island, packed with very complete semiconductor infrastructure. Not only from manufacturing, from design to manufacturing, assembly, and test. We just heard that. There's research institute like E3, and there's top-rated universities. They all pack in a very close vicinity, and all of us work very closely together, probably closer than most people will understand. So this is one of the first reasons I contend that this is very difficult to replicate in many other parts of the world. Okay, and another reason, my observation is, if you look at the products, the solutions come up by Taiwan companies, whether it's in design or manufacturing, oftentimes what you see, we are non-threatening. What do I mean by that? We are non-threatening. You look at the solution we have, usually we don't try to take a dominating position. For example, dominating a key platform or the most computational power. Oftentimes, we don't do that. And our solution, in many different ways, they complement with lots of leading technology. Our engineers, they have a very unique combination. What I mean by this, I always tell people semiconductor is a very strange industry. We heard about innovation. Yes, you need innovation. Actually, there's another element. Contrary to this, we need discipline. Semiconductor industry without discipline, you are not getting far. What I mean by that, in deep sub-micron design, there's not a lot of design margin you can have. Everything has to be very precise, especially when it comes to testing. Talk about boring job. Testing is a very boring job, but it's a necessary evil to make sure your pure product work. Taiwan, my observation, historically, we are heavily influenced not only by Western free-thinking, innovative mindset. On the other hand, we have the Eastern discipline and self-constraint, follow rules. It's a very strange combination that when you think about it, again, very difficult to find in other parts of the world. And because of the non-threatening this nature, what you see, oftentimes Taiwan companies are viewed as trusted player in many ways. And these are, hard-earned reputation. We need to continue to be that way. Last but not the least, I always say, at the end of the day, we are a high-tech industry. we need solution, we need engineer. We need solid engineering. I want to emphasize that at the end of the day, you need engineering more than scientists. Yes, it's very important you have the great innovation, but if you cannot reduce it to practice with high yield, with ease of manufacturing, you don't have the cost performance mindset, then it will be just a good this dream. You wouldn't be able to reduce it to good engineering for the mass market. And that's what we need, so solid engineering. So with all the above, I contend to say, yeah, with geopolitics, with inflation, with lots of things, we cannot control. But what I just mentioned, whether you agree that is controllable or not, I contend that we have been doing that all the time. So if we keep doing what we are doing the best, I think, yeah, the future semiconductor is way far away from reaching the limit. We just heard that Moore's law is not a linear concept. Moore's law can be a 3D concept, and for that matter, higher than 3D concepts there. So all this with a good engineering work, with innovation and discipline, I really see this is the place we are going to see far more good news from here. Thank you.
Thanks to Vice President Huang. Yes, we are not threatening, and we are really working hard. Maybe that's what are that are our advantages, and that's why Taiwan has reached the top position in the semiconductor industry. Thank you to Mr. Huang. And what's your opinion about this issue? I would like to ask President Ji-Yuan Liu.
Thank you. I think at this moment, the Taiwan status of the semiconductor industry is on the top. It's everything very good. So just like a flying wheel is rolling full speed without any external disturbance or something try to stop. I think we are going, no problem. Okay, so at this moment, what we most worry about is there is any real physics barrier over there. Then we'll stop there. All the follower will push off. So at this moment, recently, we read in the news. The NVIDIA CEO, Jason Huang, said, Moore's law is dead. But another one, CEO say, in Intel, say, no. Moore's law is alive and well. Okay, which one is right? I think either one is partially right. They're talking about this from different point of view. So if a conventional Moore's law, certainly people say slowing down. And every generation get unproportional expensive. So people say Moore's law is going to die. But actually, we, scientists and the engineer, is very smart. Actually, Moore's law is effectively continual and pray. Okay, like my expertise, the memory. NAND memory, okay? You cannot shrink in 2 dimensions. You stack on 3 dimensions, okay? And it's continuous following Moore's law. Nothing wrong. Moore's law, still 18 months, the cost stopped by half, okay, cut by half. So effectively, there are many ways to do that, okay? Chiplet, whatever, okay? I think effectively Moore's law from my point of view, I will see it can continue another 15 years, no problem. Effective more so. Okay. So for Taiwan, the most important right now is we want the government to support us with the people. Education most important, just as Mr. Huang said, people, okay? We need the electricity. We need the water, okay? If government provide this, everything will go, no problem. So I didn't see any problem. But if no electricity, no water, okay, no people, we just stop here. Okay, so the company will make all their effort. And if the infrastructure and the ecosystem exist, we like, as I said, flying whale. We are already at a full speed. Almost cannot stop. Otherwise, it just spin off, go to the other place of the world. So if Taiwan will maintain it, so please provide, as I said. That's my opinion. Thank you.
Thanks to Mr. Liu's opinion. And I would like to ask Professor Ji Wu, what's your opinion? Not Ji Wu, sorry. Dean Jackson, sorry.
Yeah, I would like to thank Minister Wu and the organizer for the invitation, and glad to be here with all the experts. As Mike Campbell said it well, Taiwan will continue to be the most trusted partner of the world semiconductor and information industry. That's going to be 13 trillion in a little over 10 years. Now, I would like to add, since I represent the new Industry Academia Innovation School, in terms of what Taiwan needs to go from past success to the future success. You all know, if you buy stock, the past performance doesn't guarantee future performance. So the whole, not only the industry, the companies, they are already playing in the major league. They are on the, and the universities here, as one example, has been constrained by all those, especially national universities, all the regulations and so forth. So the government actually, with the new legislature, are trying to remove some of those barriers, allowing, right now, I think it's like 5 or 6 schools setting up new semiconductor colleges. And the goal is, this is a new private public partnership. And the model is a two-way co-collaboration, co-creation kind of a model. We not only need, the companies needs to get breakthrough new technologies from Taiwan or from all over the world. And you need the talents to be able to put them together, to integrate them, to know what's good, what works, what may not work. And that has been Taiwan's strengths in terms of not only the supply chain, but also in terms of like the foundry companies, the fabulous chip companies. They are doing the platform business. They are providing very innovative, integrated solutions so that whoever in the world has good product ideas, application ideas, can leverage Taiwan's industry and the capability. So the university needs to go up another level. I don't mean they didn't do well in the past. It's just we need to go to a different level. So there are new, more changes and more innovations in how we train the engineers and so. But even that is not quite enough. In any case, government, as Chairman Lu said, needs to be the facilitator, need to be the partner of the private industry, the semiconductor industry, needs to loosen up more some of the regulations and provide all what Michael Porter at the factors, the infrastructures, the education, all those, so that you can unleash the innovation power of the people here, of the people in the world. Semiconductor industry in the core of all the applications, all the industry now and in the future, really is synonymous with innovation. So by freeing up, all these capabilities, these talents, training them, I think we have a bright future ahead. Thank you.
Thanks to Mr. Sun. Thanks. And thanks to Professor Wu being online with us. Thanks. And I would like to ask Professor Wu, what's your opinion?
So I think there are two most important things, and I think some other speaker probably already mentioned. And the first one is the R&D. I think before we are not in the leading position in semiconductor industry, so we can just look at what IBM and what Intel are doing, and we develop the similar technology. And now we are the leading of the semiconductor in the world. So we have to spend more effort on R&D and to develop and to do the research and to find out what's the future technology. So that need a lot of investment. So I think STC and the Ministry of Education, I think they will invest a lot of funding, research funding in the semiconductor area. So R&D spending and the collaboration between the university and the industry become more important. So I think there are a lot of programs like TSMC have collaboration with a lot of national university in Taiwan, and that's a good thing. And I hope we can continue such collaboration in the future. And the second is the talent. I think the talent cultivation in the future is more important, because now we have a lot of good engineers, but in the future we need more excellent and great engineer. So, but our engineer now mainly came from the university, and we probably need some foreign students to kind of adding to this pool, so we can have more engineer. And another area is the female engineer. If you look at the semiconductor company in Taiwan now, probably the ratio of the female and male, the female engineer, the ratio is still low. And that's the area we can put focus on, because if we have a more female engineer to kind of participate or join the semiconductor industry, I think our talent should be enough. And I think for a lot of female students, because I'm a professor too, so a lot of female students, their presentation skill sometimes better than the male student, and they doing things more carefully. So we should encourage more female students to kind of take the engineer course or take the engineer degree and go into this industry. I think this is in the future, that's something we should do. Thank you.
Thanks to Professor Wu. Thanks. Great point. Female engineers, yes. Okay, and please stay on the line, because we'd like to discuss about the talent issue deeply. The Department of Electrical Engineering of National Taiwan University has nurtured many talents in their past. However, semiconductor industry in Taiwan and around the world today are facing a serious shortage of talent, as you mentioned before, especially when Taiwan's semiconductor industry has reached a top position in the world. It has a greater demand for high-level R&D talent. So, Professor Wu, can you share with us what Taiwan universities should do in order to help industrial creating competitiveness in the next decade?
Yes. So I think the Ministry of Education, they create several semiconductor college in the past year. And I think like National Taiwan University, National Jiao Tong University, Tsinghua University, and the Cheng Kung University, we all have a good semiconductor engineer now in those national university. And now we can develop more research program. And as I mentioned, we still, because if I look at the student coming in last year, most of them are still male student. And as I mentioned, that's the female student in some area. We might need to go to the senior high school and to kind of, promote engineering education. And in our research, we need to have a more practical research and connected with the university. And as the previous speaker just said, we cannot just do science for the semiconductor. We need engineer. So we need to in order to have a good engineer type of R&D, we need to collaborate with the industry. Otherwise, we're just doing the research along with the university professor. So I think it is great to have a more program on those programs which we can connect the industry and the university together, and we do the collaboration together and try to solve the future semiconductor problem and to enable the Moore's Law to keep continuing for another 10, 20 years. Thank you.
Thanks to Mr. Wu. Thanks. And then next, we're going to discuss more about the Moore's Law. Yeah, I'd like to ask Dean Jackson. We know that Dean Jackson was the former Chief Technology Officer and the R&D Vice President of TSMC, and is now the Dean of the Industry Academia Innovation School, National Yangming Jiaoda University. As Mr. Lu mentioned before, Mr. Jensen Huang from NVIDIA said that Moore's Law is dead because even though chip technology can still improve, but the price is becoming more expensive. So I'm curious about that. Dean Sun, can you share with us your view on Moore's Law? Do you think Moore's Law is dead? And how can we overcome the challenge about increasing the investment cost of advanced technologies and technological barriers?
Yes, thank you. Yeah, I think there has been always this debate or the prophets saying that Moore's Law is dead, depending on which side you are on. And but as we all said, and you heard, keynote speakers and all the panelists, really, we are into the era of what I would call it 3D times 3D, okay? The super Moore's Law era. Which I mean is, as you've seen on the slide from Mike Campbell, that there's so many possibilities to integrate different kinds of chiplets together, and that goes hand in hand with advances on the planar, on the monolithic, what we call. You build one layer at a time, build on top for the 3D CMOS scaling, right? And the transistor is no longer planar; it's already going 3D. So even without new materials, we can already get more equivalent density of transistors on the chip. It's just one example. And there are new materials that's, it may take 10 more years or for some of them to work out all the sort of a technical challenges. But personally, I'm optimistic that right now with these FinFET extensions, these nanosheet, these gate-all-around structures, it will buy us some time in terms of getting some innovation breakthroughs in the new materials. So we can sort of get around some of the physics limitations along the way. Just like immersion lithography, which bought us time, bought us like 10 years before EUV is ready, right? And we remove one of the hurdles in terms of dimensional scaling. So really, it takes good science work in the academia, but science cross-disciplinary training for the students, like what we are trying to do, the bridge from the academia to the industry or the practical side. We have good engineers who can really see what is ready, what is good to be integrated, and to continue this empirical law in terms of doubling the density, on a footprint, on a small chip or on a small package, and every 18 to 24 months. So just like Chinese sayings, I've seen many times, 山穷水尽疑无路，柳暗花明又一村. When you go in deep in the mountain, you thought that's the end of the road, end of the world, but after a turn, with innovation, there's another world opening up. Yeah, that's my comment.
Anyone want to add? Okay, Mr. Lu.
Okay, I have a slide. I can show you.
Slide?
You see that? That's my slide. I showed this in 2 years before in VLSI TSA invited speech. As you see that 3 guys, they stand there. They take the step of scaling FinFET 3D memory and up to there. And he is also talking about all the photonics, 3rd generation semiconductor, chiplet, heterogeneous integration. All these things is on the roadmap already. That means we know how to reach there. You just need effort. So the roadmap is put there. We know how to do it. Just depends on how much effort you put and which country, which one is reach first. And reach for what? You see, you stand on the mountain. You see under there, IoT, AI, artificial intelligence, 5G, 6G, and the power management, all those things. So with the technology you in your hand, these good things you can harvest. So you see the gold, no? A lot of gold there. You go there, you get the gold. But you see something there? There is a cloud. These things are really disruptive. There is a metaverse and a quantum computing. This is a totally new game, okay? Different thing. So other than that, we have a roadmap we know how to reach. Okay, those things too are totally disruptive. But 1 week ago today, Nobel Prize announced that this year's the physics prize. Give to what? Give to 3 guys. They prove the quantum computing essential factor, entanglement of the quantum state, is real. So this is a formal recognition from the Nobel Committee at least. Say this question, Einstein is wrong. What's wrong? Okay. Quantum state of quantum entanglement really exists. What do you mean by that? That means by quantum computing and quantum communication is possible. It's already from a philosophical argument down to science, real, proved test. So what next leave to us? We engineer and the industry need to pick up this something that's feasible to realize this so-called quantum computing. This is a totally different animal. Versus all these things, that's science, technology, we all know. We also know how to achieve, just need our effort. So if we're talking about this, how you will say today, people? Frankly, I am an enthusiastic optimist of quantum computing. But today's atmosphere is a little bit too high, you know, and full of cheating group, cheating money, using this terminology, okay? But we will say good things, yes, because this is possible. 2 months before, United States, NIST, National Institute of Standard and Technology, NIST, announced they already chose 4 algorithms to be so-called post-quantum cryptography. This is 4 candidates. What they are doing? US NIST, in 10 years ago, already started this program. Say someday, if really the quantum computer has come, people are exciting about what? All our security, everything is a break. And our keynote speaker, the last one, keynote speaker, talk about the security is nothing. It's totally wiped out by this quantum computing. If this happens, the industry is in chaos, right? So we need to prepare. So the US NIST already prepared, have 4 algorithms put in there as their new standard for security. That is another thing saying quantum computing will come, but don't know when will come. And I say right now is people are too hyped. But there are several barriers. It's totally unknown how to solve. First, the quantum device is not chosen at all. Now there are 10 more than 10 choice. We don't know which one is the final choice. Just like the semiconductor. There are more than 10 devices, bipolar, NMOS, CMOS. Which one is the one? Finally, CMOS pick up the winner, right? Now, we don't know this. So fundamentally, we don't know which device is the device. Second, we don't know how to interconnect. Like the VLSI Jackson built in TSMC at all. Totally don't know how to interconnect them out. That's totally a mess right now. Third, the error correction. There are too many errors. You almost need 10,000 bits to protect 1 bit. People talking about, I can build 100 bits. This is totally error bit. No use at the moment. So how to build an algorithm to error protection? So these things are all very tough engineering technology. So there is a lot of things people can do. So the young people join our industry. Don't worry about lost your job. There are too many things, too many challenges you can choose. Okay? However, I said, there are people like venture capital get so much money nowadays. But turn out all the companies are negative. None of it making money at all. But their valuation is like huge. Some people say these are all cheating group. Okay, all the money they receive produce nothing. $0, negative dollar. But I view this as a necessary road we go to there. So many physics nowadays working on this receive maybe 10 times salary than as a professor in university. Okay, give to them to do the effort. Okay, so they spend the money. So the investor, smart investor don't care, because if the evaluation is going up, anytime he go out, still make money, not lose money. But the last rat will lose money, okay, lose everything. But the social resources put in due to this hype. So I will say this is, I don't know how to say it. It's harmful or not harmful. Okay, I don't know. But this is an exciting era. So I view very young people here. You can try to devote here. Okay.
Thanks to Mr. Lu. Well, so exciting. We have already turned into a new era. And next questions, I would like to keep asking Mr. Lu about the new technology trend. We know that Mr. Lu is Taiwan's Mr. Memory and used to host E3 submicron project and was a former president of Vanguard International Semiconductor. Today, Micronic is also a leading company in Flash. Your spirit of constantly exploring new technology trend is so admirable. And Mr. Lu, can you share with us how new technologies such as quantum technology you mentioned before, and AI and third generation semiconductors will impact the industry, and how can Taiwan react to the opportunities and the challenges of these new technologies?
Okay, this up to this question, my daily life, okay, what I operate is on a very advanced memory. Although very advanced, it's nothing to do with the quantum computing at all at this moment. And even for quantum thing, how to do quantum memory now is zero. People don't know how to do it. We're talking about quantum, is quantum communication, quantum computing, but not quantum memory, because quantum's lifetime is too fast, so cannot to fulfill that. But for us to do the memory, we also, just like an NIST, we are just put on our mind. If those kind of a processor happen, if the communication come, what kind of memory they need, okay? We can, at this moment, do this job to fulfill the new era. As I said, the NIST's algorithm is totally targeted with the quantum. Quantum can break the so-called RSA, called RSA, security algorithm. However, there are many other mathematical methods can be installed, and the quantum is no effect to them. So you can be still safe, no problem. However, to distribute the standard all over the bank and the institute of the world, according to our past experience, need a decade. Need 10 years to do the distribution. So you need to prepare 10 years before that moment happened. So at this moment, we already need to prepare. When they will be coming, we don't know. Although at this moment, it most likely not happen tomorrow. So we still have a little bit time to do.
Thanks to Mr. Liu. Next, I would like to discuss about the new application. We know that Taiwan has established a solid foundation in the semiconductor hardware industry. Taiwan's semiconductor industry has reached to a top position. However, in terms of applications, it requires closer connection and cooperation with major industries around the world. How will NSTC assist Taiwan industries, especially keep up R&D momentum in order to maintain competitiveness in new applications for the next decade? I would like to ask Mr. Lee.
Okay. Because semiconductor is the core for intelligent innovations, it is reasonable to expect that Taiwan will move toward a smart society. Artificial intelligence, big data, the Internet of Things will be applied across people's life, work, learning, and almost everything. And the semiconductor is the core technology of all these aforementioned technologies. Because the wide application of the semiconductor, we National Science and Technology Council, the NSTC, has launched several major programs to further improve and spill over our advantage in semiconductor to other areas, including the 5 following major programs. The first one is innovative medical materials, accurate diagnosis and treatment program. Taiwan has the world's most complete supply chain in semiconductor industry. Many highly competitive ICT manufacturers and the sound medical service with abundant top-notch clinical medical talents. With these advantages, we believe that Taiwan has the potential for digital medicine. The second major program is the CubeSat Key Technology R&D program. This program focuses on CubeSat constellation communication, CubeSat propulsion system technology, telemetry technology, and scientific experiments, which involve microwave, optical, and laser communication, attitude control, ground reception, optical radar and camera, and other technologies. The third major program is the key emerging chips for high-performance computing and for next generation communication. In this program, we have 3 major tracks. The first track is to develop the high-performance computing technology, for example, in the AI applications. The second track is to develop the communication IC, especially for 6G communication and sub-terahertz wideband communication IC. The third track is to further improve the EDA and the IC design environment. In particular, the TSRI, Taiwan Semiconductor Research Institute, will help to develop the design environment for the academia. The fourth major program is the next generation compound semiconductor. In this program, we would like to develop the high voltage component for the electric vehicles. The second target is to develop the high frequency component for the next generation communication. For the high voltage applications, we will focus on gallium nitride and the silicon carbon. For the high frequency applications, we will focus on gallium nitride and the indium phosphide. In addition, we will look into the new materials, for example, the diamond and the gallium oxide. The last one, the fifth major program is the quantum technology program. In early October, just about last week, the Nobel Prize in Physics was awarded to 3 scholars for their fundamental contribution to quantum technology, as we have discussed a lot today. In this program, we will further develop, for example, the low temperature silicon-based technology, quantum bit circuit design, quantum computer subsystem integration, and the peripheral related circuit environment. All of this will require solid and strong semiconductor technology. All the program I just mentioned about are the key items on our NSTC funding agenda. We hope that Taiwan edge in chip design and the manufacturing will spill over to other industries. Thank you.
Thanks to Mr. Lee. And the last question, I would like to ask Vice President Yee Huan, which this question is really important. Realtek is currently the 8th largest IC design house in the world, with strong establishment in industries such as network communication, multimedia, and so on. And today, we see the electric and the self-driving vehicle industries are booming, but Taiwan has not established much in that market, and the supply chain is really different. So what's Realtek's strategy and plan, and how can Taiwan seize the huge business opportunities brought about by EV market?
Thank you. Sounds like I'm the one sitting between you and perhaps your dinner, so I'll be brief here. Okay, so you ask about automotive. You also mentioned Realtek has been quite successful in communication, consumer, there's computing. Okay, so is it really a deviation from what we are doing? The answer is no. Actually, it's a natural migration. First, let me quickly say that all the good things we heard today about 5G vision, connecting everything, obviously, when everything is not connected, many of the things or all of the things we heard today wouldn't exist. My contention is no connectivity, no AI, no big data, no intelligence, no autonomous, no nothing. So the heart of everything is connectivity. So what does that have to do with a car? Why we even need a car? Okay, I think the pandemics have proved that we are not satisfied for being locked down in isolation. The moment we can move around, we will move around. And when you think about vehicle, cars, really vehicles is a better term. Okay, we need something to take us move around. And that something, what's happening there, I would like to quote Ford, European CEO of Ford Group, Executive Director, Mr. Herman. He said last year in Munich Auto Show, he said, my entry-level Ford Escort has 300 chips inside. My high-end electrical vehicle has 3,000 chips inside. What do you think all those chips doing in the car? Collecting information, they are computing. And do they all do that in isolation? No. all those components, they need to be connected. How do you connect them? Okay, so the idea start clicking by the automotive industry. They, before they can talk about this, connected car, they need to solve the problem first, in-vehicle connectivity. Once you do that, the doors start opening for all other opportunities. So my point here is the opportunities we find in vehicles actually is moving toward the direction of, I call it, moving to the direction of an IT platform. Now, the good news is that Taiwan industry, Taiwan companies, we are very familiar with how to compete in IT platform. As I said before, many of the Taiwan companies are viewed as non-threatening because we are not fighting the dominance of any platform. And car is moving to that direction. There will be platform-based vehicle. Just look at Tesla. Those who drive a Tesla, your car has over-the-air upgrade almost on a weekly, if not daily basis. So vehicle is becoming an IT platform. That's the opportunity for everyone in the IT industry in Taiwan. So, but don't take it for granted that with the success we have in IT, I will guarantee you any success in car. No guarantee, although that seems to be a familiar battlefield. What's the difference? At least I will tell you one major difference. Up to now, for example, when people talk about safety, security, these are two different concepts. Safety usually have to do with human life. Security usually has to do with data. Now, when people are sitting in a moving vehicle, your life depends on the moving vehicle. So the car safety will impact the person's safety. Likewise, the car data security will affect human safety. So the concept of security and safety are merging in the car. That is very important because that leads to the next concept. You have to have zero defect. Now, those who are not in the auto industry probably cannot really appreciate what do you mean by zero defect. Meaning that there's no chance to put a human life in danger. How do you achieve zero defect? Now, I will look at that as an engineering term, okay? So, to put it simple, those who are working in the IT industry look at quality as a concept I call quality by testing. Okay, you test the product you build. Those defects, you keep it in-house. Good parts, you ship it out. Those from the outside world, they look at your product after testing, they say, good quality. For auto industry, that's not quality. So the quality concept need to be changed. It's quality by design. So every phase of the design, you ask the question, how can my design fail? How can my circuit possibly can go wrong? What is my solution? So simply put, even quality by design, still that's the entry, that's the starter. Eventually, you need to go to quality by habit. Quality is a habit. if you don't have this concept, it will be very difficult for you to become successful in the automotive industry. Realtek have gone through that, transforming ourselves from an IT-centric design mindset, design by test, to design by quality. And that's the experience we would like to share with everyone. Car will become a familiar battlefield for the industry, but it cannot be taken for granted. And quality, safety, security, these are the important concepts you need to manage. Thank you.
Thanks to Mr. Huan. Thanks. Thanks to all speakers sharing your views on these issues. And as we discussed today, Taiwan's semiconductor industry is facing lots of challenges, but there are still plenty of opportunities waiting for us. Now it seems like the worst of the time, but maybe it's the best of the time. We need to work together to build the next golden decade. Thanks to all speakers again. Please give them a round of applause.
Okay, thank you, our moderator and our panelists. Thank you so much. And also, I would like to thank all of you to join the 2022 Food Text today. And at the very end, please scan the QR code on the screen. And please, you may return to the seat. Thank you so much for our panelists and our moderator. And right now for our audience, please scan the QR code. 我们现在现场的贵宾可以帮我们扫描在荧幕上的 QR code， 然后帮我们填写线上问卷。那大家呢可以凭截图到我们舞台区左手边的工作桌来参加抽奖。所以如果各位呢可以帮我们先扫描，然后填写完成之后帮我们截图填写的画面，可以到我们舞台区的左手边来进行抽奖。Once again, thank you all for joining us today at the 2022 Food Text, and hope you all enjoyed today's forum. And I will see you soon. And please, you may visit our booth around our main stage, and please fill in the questionnaire, the survey online, and you can enter the lucky draw. 请大家呢，我们截图之后到舞台区左手边可以参加抽奖。好，感谢各位今天的莅临，我们的未来科技馆，希望大家都可以有一个非常愉快的一天，谢谢。